This is the first section on chapter 1 on linear regression, and this section is about least squares linear regression. So the first thing I'm going to do is we're going to start off by drawing a scatter graph or scatter diagram. And let's say I want a way of finding the equation of the line of best fit. Now I could draw this by eye and work out the gradient and the intercept of that line, and do it that way. But we want a mathematical way. We want a more precise way of finding the equation of the line of best fit. And the method we're going to use is, first of all, by looking at the y distance between each of these points that I've plotted and the line that I'm trying to find the equation of. Now these distances here are called residuals. Basically, a residual is basically what's left over. So what's the distance between each point and that line that I'm trying to find? So these are called residuals. Now, some of these residuals are positive, the ones above the line. Some of these residuals are negative. Now, if I were just to add all of these residuals together, I would end up with 0. So what we're going to do is we're going to square these residuals. So we can work out all of these residuals, these differences here, square them, and then find the sum of these residuals squared. And what I want is that for the sum of all these residual squares, and I've drawn on the squares to help you visualize what's going on, I want the sum of all these squares to be as small as possible. Remember, at GCSE you were told when you draw a line of best fit, you want it as close to each of these points as possible. This is a mathematical way of doing it. How can I minimize or make the sum of these squares as small as possible? Well, when we do that, the line that we get is called the least squares regression line. So I've just written that down. So in the textbook, when it talks about a regression line, it's this thing that we've calculated here. Basically, the equation of this line of best fit, we call it a regression line. Now, this is just like any straight line, and the equation of that line we're going to write in this form: y equals a plus bx. A bit like y equals mx plus c. So b is going to be the gradient of our line, and a is going to be the y-intercept of our line. So I'm now going to show you how we calculate these values of a and b. First thing is that we need to calculate the value of b first, because this needs to be substituted in to find a. So to calculate b, we need to do this calculation. B is equal to something called sxy over sxx. Now don't worry, I'm going to show you how to work out this sxy and sxx. They're also in the formula book, and you'll find them on page 24. So page 24 of formula book. Now these are what we call summary statistics. We're summarizing a longer calculation by just using shorthand, basically. So if we want to calculate sxy, it's shorthand for this: the sum of xy minus the sum of x times the sum of y over n. So you can see why we summarize it by using this, because we don't want to write this out every time. We just want to write out the top part of this calculation. Now, you may see like little i's down here on the x's and y's. That basically means you're doing this to every pair of values in your table. Now, this can be quite a long calculation, so often these things are given to us in the question. If you had to do it from scratch, you'd have to multiply every x and y value, then find the sum of that, then find the sum of all your x values, times that by the sum of all the y values, and then divide that part by the number of pairs of values you've got. Okay, so that can take quite a while. It's easy to make a mistake. So these summary statistics here are often given to us already in the question. Now sxx we calculate by doing the sum of x squared. So you can see actually if we replace y with x, you just get x times x, x squared here. minus, well, if you replace that y with x, you get the sum of x times the sum of x, which is the sum of x all squared over n. So these are summarized here, and these will go into this part of the calculation. You may also be asked to calculate SYY, not in this type of question. And if you do, this is also in the formula book, that'd be the sum of y squared minus the sum of y all squared over n. So by doing this calculation here, by doing SXY divided by SXX, we get the value of B. Now, once we've got B, we can then use it to find the value of A. So we calculate A second because we need the value of B to calculate A. The way that we calculate the value of A is equal to the mean of all my Y values minus B, there it is, what we've just worked out, times the mean of all the X values. So I'll just put a little arrow here to show that that B is the one that goes there. Now, since we've used these Y residuals, or the square of these Y residuals, so the difference between where that point is and the line in the Y direction, we call this the regression line of Y on X. Okay, so when we do this calculation here, we get the regression line of Y on X, Now, if, for example, we had worked out the residuals in the X direction, so the distance between where that point is and the line in the X direction, and minimized those squares, that would be called the regression line of X on Y. But for what we need to do, we just need to look at the regression line of Y on X. So before we go into examples, just a couple of things to point out. Here we've used X and Y. Now, it could be a question uses different letters like S and T. Just make sure that you match up the letters correctly. So, for example, if we had a table like this and it had S in the top row and T on the bottom row, then S is where I would put where all my X's are in my calculations, and T would be where I put all the Y bits in my calculation, and we'd be asked to calculate the regression line of T on S. So notice how the T matches up with the Y and the S matches up with the X. And coding. So we may get questions that involve coding, in which case what you do is you calculate the equation of the regression line normally, then substitute the coding for X and Y into that formula, into that regression line that you've calculated of Y on X. So in this example here, example 1, the results from an experiment in which different masses were placed on a spring and the resulting length of the spring measured are shown below. Okay, so we've got the mass in the top row, that's X, and the length in the bottom row, that's Y. And then we need to calculate these summary statistics SXX and SXY. So when we're doing this type of question, probably the first thing we want to do is to actually write down what the formula is. Now, these are in the formula book, as I said, but you'll be writing them down quite a number of times, so you'll probably get to actually memorize what they are. So you've got the sum of X squared minus the sum of X all squared over N. So the next thing we now do is substitute in the values. So we've been given the sum of X squared, which is 22,000. So we've got 22,000 minus the sum of X all squared. So sum of X is 300. So we're going to do 300 squared. And that's going to be over N. And all we need to do for N is count how many pairs or values we've got. So N is 5. So I'll just write that down. N is 5 here. So we just divide that by 5. We can work this out on our calculator. And that gives us 4,000. And then the other thing we need to calculate is SXY. So again, we'll just write the formula down. SXY is equal to the sum of X times Y minus the sum of X times the sum of Y all over N. So again, we can just substitute the values in. So the sum of XY I can see here is 18,238 minus the sum of x, which is 300, times the sum of y, which I can see is 288.6, and I divide that by n, which is 5. So again, using a calculator, and we get exactly 922. So that part of the question is done. It's just substituting. Okay, part B says calculate the regression line of y on x. So remember, the form of the regression line of y on x is y equals a plus bx, and the first thing we need to do is to calculate b, and b is equal to the sum of xy or sxy over sxx. Now we've just calculated these, so sum of xy is 922 over 4,000, so this is going to give us the gradient of this regression line, and it gives us 0.2305. And now we're going to calculate a, which is like the y-intercept of our regression line, and a is equal to the mean of y minus b times the mean of x. Now we don't need to calculate the mean of y or the mean of x because they're given here in the question, so we can just substitute now. So mean of y is 57.72 minus b, well b is what we've just calculated, 0.2305, times by the mean of x, and I can see there is 60. So it gives us the value of a, so we'll calculate this on a calculator, and it gives me 43.89. So now I can calculate or write down now my regression line, which is going to be y equals a, which is 43.89, plus b, which is 0.2305 times by x. So there's our line of best fit calculated mathematically. We'll move on to part C. Part C says use your equation to predict the length of the spring when the mass applied is, in part A, 58 kg, so mass equals 58 kg. So the mass is x, so we're substituting x into our regression line. So that will be y equals, and y is going to be the length, 43.89 plus 0.2305 times by 58. Let's work that out. And that gives me 57.259. And that's going to be centimetres. Probably want to give that to 3 significant figures. So 57.3 centimetres is what we're expecting that length to be. I think we're going to be commenting on that in the next part of the question. And part 2 here, the mass is 130 kg. So just substitute 130 into our regression line. So 43.89 plus 0.2305 times by 130. And that gives us a length of 73.855 centimetres. So again, we'll give that to 3 significant figures. So we'll say 73.9 centimetres. And lastly, we'll just move on to part D. We want to comment on the reliability of these predictions here. So starting with the 58 kg, well, if we have a look, the data that we collected was from masses of 20 to 100. 58 is within that range, so we could say, you know, that this is a reliable result because it's in the range of data that we've collected. However, the 130 is beyond the range of data that we've collected. We've extrapolated, so this is not a reliable result here. We don't know how the string is going to behave beyond a mass of 100 kilograms that the actual spring might break. It may act completely differently because we're extrapolating, it's outside our range. So we'll just going to summarize what we've just said. So you can see that summary down here, which we've just spoken about. Example 2. A scientist working in agricultural research believes that there is a linear relationship between the amount of certain food supplement given to hens and the hardness of the shells of the eggs they lay. As an experiment, controlled quantities of the supplement were added to the hen's normal diet for a period of 2 weeks, and the hardness of the shells of the eggs laid at the end of this period was then measured on a scale from 1 to 10 with these following results here. So the top row is our food supplement. So when we have our summary statistics, this is going to be where X is, and the bottom row, the hardness of the shell. That's what I'm going to look for YH. So part A, we want to find the equation of regression line of H on F. Now it's important that we get the letters the right way around. Now normally we would see this as the regression line of Y on X. So since our regression line is of the form Y equals A plus BX, we need to make sure that we put H and F in the right place. So H is where my Y is going to be. So H equals A plus BF. So remember, we need to start by finding F first. So F is like our, or sorry, we start by finding B first. So B is like our, if it was using X and Y, then it would be SXY over SXX, but we're not using X and Y, we're using H and F. So this would be SFH over SFF. So we'll write out the full formula. So that's the sum of FH minus the sum of F times the sum of H. That's over N. That's going to be divided by the sum of F squared minus the sum of F all squared over N. So now we can just substitute in the numbers. So the sum of FH is here. So that's 422.6 minus the sum of F, 56, times by the sum of H, which is 45.8. So we've got 56 times 45.8 over N. So how many pairs of values we've got? 1, 2, 3, 4, 6, 7. So I'll just put down here that N equals 7. And all of that is going to be divided by the sum of F squared, which is 560, minus the sum of F, which is 56, and we're going to square that. So it's 56 squared over N, 7. So the top part of this is 56.2. We'll calculate the bottom part, and that's 112. So this is just calculating B, so 56.2 divided by 112, and we get 0.50178, like that. So we're probably going to put that maybe to 4 decimal places or 3 significant figures in a moment in our formula, but we're going to use the exact value to calculate A. Now A would be the mean of Y minus B times the mean of X, but we're not using X and Y. So remember that where we've got Y, that's the bottom row of the table, that's now H. So the mean of H minus B times the mean of X, which is the top row of the table, so the mean of X. So A will equal the mean of H, that's 6.543. And just a note here, if we weren't given the mean of H, then we could just take the sum of H and divide it by N, which is 7. So you can check for yourself, if you do this divided by 7, then we should get the mean of h there. Then we're going to minus b, which is the 0.50178. So I'm going to try and use the exact value if I can, times by the mean of x. So that's going to be the mean of f. And the mean of f is there, which is 8. Again, if you weren't given a mean of f, you can just take the sum of f and divide it by n. So we can times that by 8 to give us a. Now that gives us 2.5287. Again, it carries on. So what I did here, because I wasn't able to recall that exact value, I just used the 56.2 over 112, which I've just previously calculated over here. Okay, so now I'm ready to give my regression line. So h, the hardness of the shell, is equal to a. Now I'm going to give my answers to 3 significant figures, so 2.53, plus b, again to 3 significant figures, 0.502, times by f, the amount of grams of food supplement that is given to the chicken. I believe they're chickens or hens. Now just moving on to the last part of this, interpret the values of a and b, or interpret what the values of a and b tell you. Well, first thing, a is like our intercept. So that tells us the value of h when f is 0. In other words, and we need to interpret it in the context of the question, the hardness of the shell when no food supplement is given. So we'll just write that down. Then we need to interpret b, which is like the gradient of this regression line. So for one increase in f, h goes up by this gradient by 0.502. In other words, it tells you the increase in the hardness for every 1 gram of supplement per day that is added to the feed. So we'll just write that down. So b is the increase in the hardness, which is 0.502 to 3 significant figures for every 1 gram of increase of supplement per day or each day. Example 3. A repair workshop finds it is having a problem with a pressure gauge it uses. It decides to have it checked by a specialist firm. The following data were obtained. So it's my x values along the top row and my y values along the bottom row. And what we need to do in part A is show that SXY equals 6.776 and find SXX. So we'll start with our SXY and actually calculate it. So using the formula from page 24, that's the sum of XY minus the sum of X times the sum of Y over N. So I believe we've been given those. So the sum of XY is 52.04 minus the sum of X, 19.2, times the sum of Y, 18.86. And we're going to need N as well. So I'll write that down. We have 1, 2, 3, 4, 5, 6, 7, 8 pairs of values. So N is 8. So that's going to be divided by 8 here. I'll calculate that. And if we work that out, and I've realised that should be 18.86, not 18.6. As a fraction, we get 847 over 125. And SD button 6.776. So we get the value, or we've shown that SXY equals 6.776. Now we're going to calculate SXX. So it's going to be the sum of x squared minus the sum of x all squared over n. So the sum of x squared is 52.8. minus the sum of x, which is 19.2, that's going to get squared over 8. So as a fraction, that's 168 over 25. And my SD button tells me that's 6.72. Okay. Now it says it is thought that a linear relationship of the form y equals a plus bx could be used to describe these data. Part B, use linear regression to find the values of a and b. Give your answers to 3 significant figures. So we start by calculating b first, which is the sxy over sxx. So you've calculated these two already. So that's going to be 6.776 over 6.72. That gives us 121 over 120, which is 1.008, and it looks like it's 3 recurring after that. We'll use that to 3 significant figures when we write our equation down. So we'll call that 1.01 to 3 significant figures as they want. And now we'll work out the value of a, and a is the mean of y minus b times the mean of x. So that means a equals the mean of y. Now you can see in this one the mean of y is not given, but we can find it by doing the sum of y over n. So that's going to be 18.86 over 8, so there's a mean of y, minus b, so I'll use 121 over 120, the exact value, times by the mean of x. Again, the mean of x isn't given, but I have the sum of x, so the sum of x over n is going to give me the mean of x. So we'll calculate a. That gives us a equals negative 1 over 16, and that's negative 0.0625. That is to 3 significant figures. So we can give our regression line as y equals a, negative 0.0625, and then bx, so plus b, which we've got as 6.72x. Sorry, I'm looking at the wrong number there. My value of, I was looking at that one here. Now, value of b is here 1.01. So 1.01x. Okay, we'll move on to the next part of the question, and that's asking us to draw a scatter diagram to represent the regression line on your diagram. Okay, so here's my scatter graph. I've got these points just by putting in values of x, 0, 1, 2, 3, 4, 5, and getting out y values. And you can see it's almost like the line y equals x because of these values here. So the last thing I've done is just label up the axis. It's important to do that. So now we'll move on to part D. The gauge shows a reading of 2 bars. Use the regression equation to work out what the correct reading should be. So this is just a matter of substituting into our equation. So we've got this reading down here, which is the gauge reading of 2. So that's our x value. So we'll replace our x value with 2 to find what the correct reading should be, the y value. So y equals negative 0.0625 plus 1.01 times by the reading of 2. So we'll just work that out and see what we get. And that gives us a value of 1.9575. So we'll give that answer to 3 significant figures, and we'll give that as 1.96. And the units are bars, so 1.96. Now, if we had used a slightly different value for our value of b here, this would be slightly different. So you might find in the book they've given a value of 1.008 for the value of b, but the question does say give your answer to 3 significant figures, and 1.008 is actually 4 significant figures, not 3. So you should now be able to do exercise 1A on pages 6 to 8 of the textbook. Example 4, what we've got here are 8 samples of carbon steel were produced with different percentages C of carbon in them. So if it's 8 samples, let's write down straight away that N is 8. I can see that because there's 8 columns as well. Each sample was heated in a furnace until it melted, and a temperature M in degrees Celsius at which it melted was recorded. The results were coded such that X equals 10C and Y equals M minus 700 over 5. The coded results are shown in the table, which we can see here. Part A, we want to calculate S, XY and SXX. So we'll start with SXY, which is going to be the sum of XY minus the sum of X times the sum of Y over N. So we can just substitute in, and the sum of XY is 478 minus, now we're not given the sum of X or the sum of Y, but we can work them out. Sum of X is just going to be all of these numbers in the top row added together, and the sum of Y is going to be the numbers in the bottom row. So let's add those up and see what we get. So when we do 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, that'll give us 36. And then when we add together the numbers in the bottom row, 35 plus 28 plus 24 and so on, that gives us a total of 144. So we just use our calculator for that. Okay, so the sum of X is going to be 36 times the sum of Y, 144 over N, which is 8. So we'll now work that out. And we get exactly minus 170. And now we'll work out SXX. So that'll be the sum of X squared minus the sum of X all squared over N. Let's get rid of that and put the squared there. So sum of X squared we're given. Over here it's 204 minus the sum of X, which we've worked out, which is 36 squared over N 8. So I'll calculate that. And that gives us exactly 42. So we have our answers for part A, SXY minus 170, SXX 42. Part B, it says find a regression line of Y on X. So remember we start by finding B. B is SXY over SXX. So that's going to be negative 170 over 42. Now that actually becomes negative 85 over 21. Now as a decimal, that's going to be negative 4.04761. Okay, like that. And now we'll calculate A. So A is going to be the mean of Y minus B times the mean of X. So the mean of Y, well, that's just the sum of Y over N. So it's 144 over 8. Minus B. Now I want to use the exact value for B, so I could either use the fraction button, or I can use this negative 85 over 21. It's handy when you've got things as fractions, because you can just put them in like that. So minus B, B happens to be negative, times by the mean of X, and the mean of X is just going to be the sum of X over N, so it's going to be times by 36 over 8. Now that gives us exactly 507 or 507 over 14. If we use the SD button, that will give us 36.21428 and so on. So now we'll write our regression line. So that's going to be Y equals A. Now for A, I could use the decimal I've got here, or I can write it exactly like this. Let's write it as 507 over 14. It just means when I come to do any calculations, I'm using the exact value for A. It's not always possible. If you don't have this exact value, it's a decimal, I'd probably use at least 4 decimal places, so that we can then write to 3 significant figures afterwards. So it's A plus bx. Now b also happens to have an exact value, 85 over 21. So plus negative 85 over 21, or just minus 85 over 21x. So there I've got a nice exact regression line formula here. So we'll now move on to part C. And part C says, estimate the melting point of carbon steel which contains 0.25% carbon. So this is where you need to use the coding, because you want to find M given that we have C. So the easiest way to do it is basically just to substitute X for 10C and Y for M minus 700 over 5. So we'll do that up here. So part C, the equation now becomes Y, which is now going to be M minus 700 over 5. So we substitute My for that, equals 507 over 14. Let's just put minus here, minus 85 over 21 times by X, and X replaced with 10C. Like this. So it's just substitution. So you can see the substitution's taken place here for Y and here for X. So now we've got a regression line in terms of C and M. Now we know that C is equal to the percentage of carbon. That's 0.25. So we replace C with 0.25. So let's just get rid of these. So we've got a bit more space. So what we'll have now is M minus 700 over 5 equals 507 over 14, and then minus 85 over 21 times by 10 times C, which is going to be 2.5. So let's work out all of the right hand side now, and that gives me exactly 548 over 21. Where you've got these exact values, try and use them, and then we can just rearrange it to find M. So we're going to times this 5 by 5 and then add 700. So times by 5, add 700. Now I do get an exact value here, but I'm probably going to give my answer as a decimal. So using the SD button, I get 830.4761905. So let's go for 3 significant figures. So we'll get 830 degrees Celsius. So notice I've tried to use exact values where I can through the calculation and not rounded until the end. So in your regression line, even though you might write the values of A and B in the regression line rounded, don't use those rounded values in your calculation. Try and use the exact values if possible. So you should now be able to do exercise 1B on page 10, and there's a quick recap here if that's useful for you.